Today, we're going to journey to a rather faint but oh so deeply storied constellation, Capricornus. We're going to dissect it, really from two powerful perspectives: the hard physics that dictates the lives of its stars, and the ancient myths that have given it meaning for thousands of years. So let's get right into it.
And the answer, well, it's hidden right there, among the dim stars of the sea goat. You see, Capricornus is this fascinating crossroads in human history. It's a place where the cold precision of mathematics, the violent drama of stellar physics, and the enduring power of ancient myth all just intersect. Our mission here is to untangle all these threads and see what they tell us, not just about the cosmos, but maybe about ourselves too.
So here's our plan. We'll start with the enigma of the fish goat itself. Why that shape? Then we'll map out its place in the sky. After that, we'll zoom right in on the illusions and discoveries hidden among its stars, and then dive into the abyss, a star cluster called M30. From there, we'll explore the incredible myths of gods and titans. And to finish, I'll give you a practical guide to finding Capricornus for yourself.
Right, so let's start with the most obvious question, why a fish goat? It's strange. This is one of the oldest constellations we know of, and for thousands of years it's been this paradoxical hybrid. But this isn't random. No, it's actually a powerful clue that's been left behind by ancient astronomers.
You see, this shape, it's a key. It's a key to a really crucial moment in the ancient year. For those early sky watchers, this part of the sky marked the winter solstice, that moment the sun hit its lowest, weakest point and began its slow climb back, promising the return of light and life. So the fish goat, it's a perfect symbol for that transition. You have this tenacious goat climbing out of the dark cosmic ocean, just as the sun begins its climb out of the depths of winter. Pretty clever, huh?
Okay, so now that we get the why of the fish goat, let's dig into the what and the where. To really understand anything in the sky, you first have to map its coordinates, get a sense of its scale. And that's exactly where the science of astronomy comes in. So, how big is it really? Well, the numbers give us a good sense of scale. It covers about 414 square degrees of the sky. That puts it at 40th in size out of the 88 modern constellations. So, it's not a giant, but it's not tiny either. It's middle of the pack. And on a really dark night, you can spot about 50 of its stars with the naked eye. So it has a definite shape, but let's be honest, it's not one of the more spectacular displays up there.
One of the really great things about Capricornus is its location. It sits near the celestial equator, and that means most people on Earth can actually see it. If you live anywhere south of 60 degrees north latitude, and that's a lot of us, you've got a front row seat. And that accessibility is a huge reason why it's been such a familiar sight to so many different cultures all throughout history.
And of course, like any constellation, it has its season. The best time to look for it is from July through September. That's when Earth, in its orbit, puts Capricornus directly opposite the Sun, so it's riding high in the sky around midnight. But from late January to mid-February, forget it. The Sun is passing right through it from our point of view, and is just completely washed out by the glare.
All right, now for the fun part. It's time to zoom in. We're going to shift our focus from the constellation as a whole and take a much closer look at some of its most remarkable stars. And what we find here, well, it's everything from elegant cosmic illusions to landmarks of incredible scientific discovery. Okay, our first stop is Alpha Capricorni, or Algedi. Now, to your eyes, it looks like a close pair of stars, a double star. But this is a complete illusion. It's just a trick of perspective. Prima Gedi, the first star, is a staggering 690 light-years away. Secunda Gedi is much, much closer to us, at only 109 light-years. They have absolutely zero physical connection. They're separated by almost 600 light-years of empty space. They just happen to light up perfectly from our vantage point here on Earth.
Now, let's talk about the brightest star in the constellation, Deneb Algedi. And it's not just one star. Oh no, it's a complex system of at least 4 stars, all gravitationally bound, all orbiting each other. The main component is a white giant, and it's what we call an eclipsing variable. So picture this. A tiny eclipse is happening with incredible precision. A companion star passes in front of the main one every 24.5 hours, on the dot, causing the light we see to dim just a little bit. It is a perfectly timed cosmic clock.
But the real claim to fame for Deneb Algedi isn't its own properties, as interesting as they are. No, it's its place in history. This star served as the crucial signpost, the X marks the spot in the sky that led astronomers straight to the discovery of Neptune. I mean, this was a massive triumph for physics. It proved, for the very first time, that the laws of gravity could be used to predict the existence of an entire unseen world. The math pointed the way and the telescope confirmed it. Absolutely incredible.
All right, now we're going to dive deep, really deep. We're going into the most extreme environment inside Capricornus, the globular cluster Messier 30. We're moving beyond individual stars now, into a realm where hundreds of thousands of them are packed together in this dense, chaotic dance of gravity.
M30 is a perfect example of what we call a core collapsed cluster. To picture this, imagine a bustling city of stars. Over billions of years, the heavier stars, they slowly lose their orbital energy through countless tiny gravitational interactions. Think of it like a kind of cosmic friction, and they sink slowly towards the center. This creates a feedback loop, a runaway process, just pulling more and more stars inward, until you get a core of almost unbelievable density, a place where stars are packed practically shoulder to shoulder.
Now, this kind of extreme density creates some truly bizarre stellar objects. Among the most fascinating are what we call blue stragglers. Now, think about this. Globular clusters are ancient. Their stars should all be old and red. But when we look into the core of M30, we see these hot, massive, brilliant blue stars. They look young, but they're living in an old folks' home. It's a total paradox. So, where did these cosmic trespassers come from?
The answer is a kind of stellar vampirism. In that crowded core, lots of stars are locked in these close binary pairs. So, as one star in the pair gets old and swells up into a red giant, its outer layers of hydrogen get really loosely bound. Its smaller, denser companion can then use its gravity to start siphoning off that fresh fuel onto its own surface. This mass transfer basically refuels the smaller star. It makes it more massive, hotter, and bluer. It rejuvenates it, but at its companion's expense.
So, we've seen the physics of Capricornus, the illusions, the discoveries, the stellar vampires. But that's really only half the story, isn't it? Let's turn to the human side now. How did ancient people look up at these same faint stars? And what stories did they see? These myths, they weren't just simple tales. They were a way of making sense of the universe.
And you know what's just amazing? It's how consistent the image of this creature has been. Thousands of years ago, the Sumerians connected it to their god Enki, who was this hybrid deity of wisdom and water. Then, 2 millennia ago, the winter solstice happened when the sun was in this constellation, and that's why we still have a Tropic of Capricorn. Now, thanks to the slow wobble of Earth's axis, that point has since drifted into Sagittarius, but the name stuck.
The most famous myth, though, the one most of us know, comes from the Greeks, and it begins with a cosmic crisis. The monstrous Titan, Typhon, a creature of just unimaginable power, declared war on the gods of Olympus. He threatened to tear down the entire cosmic order, and the gods, for all their power, they were terrified. They fled. In the middle of all this chaos, the wild god Pan, the satyr, made a desperate run for it. He leaped into the river Nile, trying to shapeshift into a fish to hide from Typhon's rage. It was a last-ditch, totally panicked effort to save his own skin. But, in his haste and his terror, he botched the spell. The part of his body that hit the water first turned into a fishtail, but his top half, still in the air, became that of a goat. And so, right there, in that moment of panicked failure, the iconic fish goat was born. But here's the brilliant twist in the story. This bizarre, accidental form, it turned out to be exactly what was needed. Pan was actually able to help Zeus recover his stolen power, which allowed the king of the gods to finally defeat Typhon. So Zeus immortalized the fish goat in the stars, not as a symbol of failure, but as a monument to how ingenuity, and even victory, can come from the most unexpected places.
Okay, so let's bring all of this together. Let's make it practical so you can actually go outside and see these very same stars for yourself.
First, to find the constellation, look for the bright stars of the summer triangle. You can't miss them. Then just draw an imaginary line from Vega straight through Altair and keep going. It will point you right to Capricornus, which looks like a large, faint arrowhead in the sky. Now, if you grab a pair of binoculars, you can easily split that optical double Almagest into its 2 separate stars. And if you have a small telescope, scan the eastern part of the constellation for M30. It'll look like a small, fuzzy snowball of light. And that's it. That's the core collapse cluster we were just talking about.
So what are we really seeing when we look up at Capricornus? Is it just the cold, hard math of the universe, a place of orbital mechanics that led us to a new planet, and stellar physics that creates cosmic vampires? Or is it also a mirror,
reflecting our own ancient stories of fear, of failure, and of unexpected heroism. Perhaps the truth is that it's both. It's a window into the physical universe and a window into the universe of meaning that we build for ourselves within it.